Hello everyone. So today I'm going to tell you how to do software engineering using AI. And in particular, I'm going to tell you how to do software engineering using Sorcar. And the one thing I'm going to highlight is that I built Sorcar using Sorcar in 4 months. And I'm going to tell you what I learned in this process and how I built Sorcar. In this first part, I'm going to tell you some of the patterns that I used, and in the later parts, I'm going to tell you more advanced patterns, software engineering patterns that I used for building Sorcar and optimizing it. Okay. So here is a snapshot of the database that I maintain for all the tasks that are being executed by Sorcar. And this is the period of time, 44 days, where I spent a lot of time in building the KISS Sorcar. It was in the middle of the semester while I was teaching. I issued like almost 3,000 plus tasks and many chat sessions and 44 days of development, and I got KISS Sorcar out of it. Okay. And the most impressive part of the KISS Sorcar is if you look at the core code for the agents without counting the empty lines or commented lines, it's only less than 3,000 lines of code. It's so simple. It's multi-model, it's multimodal, it's multi-agentic, and it has many more features. It can do AI discovery, it can do prompt optimization only via prompts. Okay, a lot of software systems reduces to 2 or 3 sentences in Sorcar. So I'm going to show you how to do that. So yeah, over time I spent I used Sorcar. It became powerful, and that's when I started implementing more and more features. And at this time, it has way more features than the popular tools like Cloud Code and Cursor. And trust me, they all work without bugs. Okay, if you find bugs, just let me know, post it, send me an email. It will get fixed in an hour if it is critical. So I do that. Okay. So you can see that when I compare Cloud Code and Cursor against Sorcar, it has many useful features. First of all, Sorcar has a Cloud Code style CLI interface, a Visual Studio interface similar to Cursor, and also it supports web and mobile app that you can use to access your laptop from anywhere in the world, from any device, having a browser. And I use it on my iPhone and Safari browser to do remote coding a lot of time. Okay, and also to monitor the progress of the tasks that are running for hours. Also, it supports AI discovery, which I'm going to talk later in a later part, and JPA prompt optimization. I don't have implementation for them. The algorithms are described using a few sentences in the prompt, and they actually get things done. And I have several examples, and I'll talk that in a later part. And then it also support multiple models. So in a given task or a workflow, just by in the prompt you can tell which model to use for which subtask. You can even write an orchestrator in natural language using 3 or 4 sentences in Sorcar that will do all the orchestrating. There is no need to have specialized software from Sakana or Open Router to get the benefit of multiple models. Okay, and I want to remind you, Sorcar I developed because I got frustrated with Cloud Code and Cursor. They have so many bugs, they introduce so many AI slops. I wanted something that I can trust on. And I'm still building it so that it meets my requirements first and so that I become faster. Okay, so it supports multiple models. You can write multi-model workflow using just prompt. The primary focus is its quality, very high quality code, very well tested and verified. It prefers quality over speed. which is kind of speed is important for both Cloud Code and Cursor. So that is not the goal. As I said, the core agent has very few lines of code. When I created this slide, it was 2500, but it stays below 3000 over time. It supports many models. You can, and also local models. And also, it has all the third party agents or channels like Slack, Gmail, and so on that are there in OpenClaw. And also it can run Cloud Code or Codex. If you have implemented the CLI tools, it can use them actually instead of other models or API key to carry out the task. Okay, so it has many features. Over the usage, over the development of the Sorcar software, I logged all the tasks and I asked Sorcar to analyze those tasks. And it told me that there are a few usage patterns that I use repeatedly, and I realized yes, I use them, and those patterns turned out to be very powerful. At least for me when I was developing Sorcar. Okay, so I'm going to tell a few of them in this part and the rest in later parts. Okay, so one thing that I always do is stress-driven development. So whenever I give it a task, Sorcar, I would first say that if it is a bug fix or an issue, I first say that first write an end-to-end or integration test that will actually reproduce the bug or the issue. Okay, so this is very important because if you don't do that, even the bug is fixed or not there, a lot of models actually start working on it and modifying it without telling you what it's doing. Okay, so it's very important that I tell the Sorcar to first generate end-to-end tests reproducing the issue or the bug, and then I say to run it or to fix the bug, and then I say run the test again to validate that we have fixed the issue, and then I also tell it to actually get it reviewed by another powerful model, say GPT 5.5, and then based on those review, I also ask it to fix the bugs. Okay, and this is kind of a repetitive process. So test first software engineering is very important. Once you have written, and I also ask Sorcar to write 100%, achieve 100% test coverage, because this test at the end of the day becomes the guardrails, and because of them you can change your software without the worry that you might get into regression bugs or bring back the old bugs. Okay, so this is a very important thing that you must do while you are developing a big software. The second one is iterative feature construction. I see that when people are using Cloud Code or Cursor, they all support a plan mode where the user is supposed to write the entire plan of how to implement a feature or a particular software. I try to use it, but I realize that creating a static plan ahead of time is not how human beings work. We do not plan in such a detailed way before we develop a software. And also another reason is software always changes, it evolves over time, so there is no way you can write a static specification and expect that Cloud Code or some AI agent will stick to that and stick to that forever. Okay, so I do not write specification. The other thing is I have noticed that as the agents perform work based on the given task, it actually tries things and it actually evolves the plan. Something is not feasible, it figures it out by running it. And if you kind of create the plan statically ahead of time, that possibility is not there because the agent is not running the code or implementing it to check its feasibility. Okay, so I always do iterative feature construction. For example, I built this Kiss Sorcar as a VS Code extension, and then I realized that I have to actually also create an web application or a browser application so that I can access the Kiss Sorcar agents and its tasks remotely. So what I did is I gave a very simple prompt. I said that implement a feature where user can access Kiss Sorcar from any device with a browser. Okay, and then it implemented something, it didn't work, and then over 60 plus iterations I started fixing the various issues and the bugs that were introduced or that were present in the first implementation. And the spec emerges from the use. There is no design document. Each refinement was prompted by actually using the feature and hitting a limit, right? So this thing I find this kind of iterative feature construction to be very effective when you're building a large software like Sorcar and implementing a big feature. Static specifications are useless in such cases. You have to do this kind of iterative construction using very small prompts, and that's what I did, and I managed to port it to the webs. And also another thing that I do, another pattern that emerged in the development of the key circle, I run a bunch of periodic code hygiene checks. For example, I would run the linters and the type checkers from time to time. I would ask it to go over all the code, and if some code has no 100% code coverage, then I'll ask it generate test for that code and make sure that all those tests passes. And if you in the process it find bugs, it should fix them. So all this kind of periodic code hygiene things I do. Sometimes I also provide it with invariants, and I ask it, these are the invariants of the system. Try hard to find violation of these invariants and fix them. And I run it overnight over a bunch of invariants, and the next morning I have something which is not only working but is much more robust. So this is another practice that I follow in Sorcar. The other thing is Sorcar evolves over time. In fact, the first agent, relentless agent, which can work for hours to days, was developed using an evolutionary algorithm. I actually wrote down a new agentic strategy called recursive language model, and I used it as the first agent in Circa. But then I found the limitations of this recursive language model, where it can go into infinite recursion, never get back, and other issues. So then I wrote an agent evolver, where I asked to reduce the cost and the time necessary to solve very long horizon tasks using the agent, and I asked to evolve the agent Kisarka, and it came up with this relentless agent which is like session based and which can run for days without any worry about context compaction or anything. So that actually evolved over time through Sorcar. Another thing I do is I improve the system prompt from time to time. I usually run this prompt, sometimes look at the week's tasks and their trajectories from the agent, and then I say which instructions in the system prompt are not being followed. Then write a test with a real task and real LLM call to reproduce each of such issues, and then fix the system prompt. And I can do it with respect to different models, different tasks, and so on. And that's how the system prompt evolved, and that's why it is so robust and powerful and forces Sorcar to do rigorous software engineering. Okay. And finally, as I said, that Circar is the center of everything. I do everything using Circar nowadays. So I use it for general shopping, browsing, doing research on the internet, communicate with others, and and many IoTs, home automation, and so on using Kiss Sorcar. So those things. So Kiss Sorcar is not just a software engineering agent; it's a general purpose agent. All you need to do is to worry about the prompt, and I recommend you to write small prompts. Okay, because Kiss Sarkar has been directed, if there is ambiguity or shortcoming in the prompt, it will go and search the internet and find the most modern and widely used solution for that ambiguity. Okay, and that works really well in practice. I also wrote a paper on Kiss Sarkar using Kiss Sorcar, and actually I evolved this paper, which is on the Kiss Sorcar, along with the code. Okay, and this is kind of an amazing thing. I don't write the paper anymore by hand. It updates itself as it is coding, and you can actually read that paper, how I wrote this Kiss Sorcar paper, at this URL given by the QR code. Yeah. So